So what is the bigger view of microplastics? Why does it matter? We have found microplastics everywhere we look. Every watershed is contributing to this one singular ocean. And we're finding microfibers and microplastics across the ocean surface. And it feeds these clouds of microplastics in the oceans. We call this plastic smog, which have different kinds of harm.
So we've known for many years now about the larger plastic litter that we can see. But just how widespread these teeny tiny microplastics are is very new. They've got unique impacts to wildlife as well.
So should we be surprised that a lot is there? Probably not. But what we really need to understand is how much is coming from the stormwater, how much is coming from ag runoff, and how much is coming from wastewater treatment plants, and then can we start to think about cutting it off at those sources.
So the San Francisco Bay Microplastics Project is a pretty unique project. It's the first regional and comprehensive investigation of microplastics. And it's set here in an urban estuary that we consider a great laboratory for contaminants derived from our cities.
Push all that stuff right in.
We all got together to look at the distribution of microplastics in the San Francisco Bay, trying to figure out how much is there and where it's coming from.
So the project was designed to bring together a lot of different stakeholders to not only carry out the research, but really think about solutions and think about what kind of policies locally and statewide can be passed to really address the issue of plastic pollution.
Because this was a comprehensive study, we looked at microplastics in a lot of different places. We looked at the surface of the bay and out the Golden Gate at the marine sanctuaries.
So just make sure that you're coordinating with Becky or I on sort of collecting that data whenever you put in a piece of equipment. As long as it works, it's pretty straightforward.
So this is our manta trawl. It collects a surface sample. This allows us to look at all of the micro and macroplastics floating in the bay.
We have a lot of pieces of styrofoam and definitely found some fibers that we could see, so there's probably some ones in there you can't see.
So we're going to be sending these to Chelsea Rockman in her lab and going to actually be processing these samples.
There's a fragment right there. See it? There's for sure plastic in this thing.
We also looked at how microplastics get into the bay. So we looked at wastewater, which is all the water we send down the drain from our homes and businesses, goes to the sewer system, the treatment plant, and then out to the bay.
We're collecting effluent sample from 8 participating wastewater treatment facilities. At this site, they do tertiary treatment, which means that it goes through an extra treatment process after the secondary treatment, which is what most treatment plants have. One of the aims of the study is to see what type of treatment processes might affect the number of microplastics that we see in the final sample. So this is a sample after 2,800 gallons of water have flowed through. It's really hard to tell what we have found until we bring it under a microscope for analysis for microplastics.
We also looked at stormwater, which is all the rain that washes through our cities and streets, heads to the storm drain or the creek, and then heads out to the bay.
I'm alternating it back and forth between about a foot deep.
This is about 25 gallons worth of water that's passed through this sieve. And there could be microfibers in there and little small bits of plastic. That's what we're going to be looking for.
The samples come in, the plastics are extracted, they're quantified under a microscope, that's brought to the Raman or the FTIR to identify it. So we're kind of in charge of quantifying how much is there and what type is there. So that looks like a pre-production pellet from industry. So that's like the raw virgin material of plastic that then gets melted down and turned into a plastic product. And then eventually helping in terms of how do we write it up and what types of policy briefs are we writing.
Finally, we took all this data and we did some cool computer simulations with it to figure out where different types of plastic might end up in the bay as well as out in the marine setting. So with this project, not only are we advancing science very specific to the bay, but we're advancing the entire field with new methods and new ways of analyzing data. So when it comes to wastewater, it turns out the facilities with extra filtration had lower concentrations of microplastics, which suggests that maybe this additional treatment has additional benefit of removing some of the microplastics in water. Another big surprise with our study is just how high the levels are in the bay. Following a storm event, levels of microplastics in bay water were some of the highest ever observed around the globe. And it turns out our stormwater has concentrations over 100 times greater than our wastewater. We also caught a lot of teeny tiny prey fish, like little anchovies, out in the bay. Now it turns out these prey fish are eating microplastics, especially little bitty fibers.
There's microplastic in our drinking water, there's microplastic in our salt, and there's microplastic in our fish, and how does it affect humans? And we can make hypotheses about those answers based on the prior literature, but what I really hope is that people from the medical field jump in on scene and start to think about mass models and other models for understanding impacts.
When we're thinking about the big solutions to plastic pollution and microplastics in general, we really need to look way upstream. So how are these products made? Why is there so much plastic in the product itself? What is the packaging? And really think about the solutions in terms of design, innovation, alternatives, and then just using less plastic. Our research found microplastics that can be linked to single-use plastic items. And our hope is that the results of the project will be used to support local efforts to reduce single-use plastic items in communities around San Francisco Bay and statewide.